this lecture, we're going to build a very simple world created with cubes. And we're going to use the code that was presented in the previous lecture, where there was a nested for loop and it was instantiating cube prefabs on the screen at an X, Y, and Z location. So to follow along, open up Unity, and what you'll need for this is a script called Camera Controller, which I've included with the resources for this lecture. Now, this script you can add to your main camera, and what it will do is make your main camera behave in a similar manner to the one that you get in the scene. So in the scene, we can use Alt to orbit, and we can use Q to pan around. This is the keys. And when we're running this, the camera control script added to the camera will allow you to do the same things in the game window, which is useful when you're trying to move around and look at things that you're building. So begin by creating a new project and bring in that script and apply it to the default main camera. So let's begin. First of all, in the hierarchy, I'm going to create an empty. So right click and create empty. I don't want it attached to my camera. And let's call it world. And onto it, we're going to add some code called world controller. So in your project, we'll go create C# and we'll call it world controller. And then attach that file to your world. Then check in the hierarchy by clicking that it is in fact added in there. Let's open that file up and we will add some code. The code will take in a prefab which will represent our block, and we'll create that in a minute. So that's our first public at the top here. I've also got a public variable in integer which will be our world size. And this will be used to set the width, the depth and the height, so it'll all be the same dimensions. Next, I've got an enumerator build world function added here. The reason I've got this as an I enumerator is so that we can loop through it but also have a rest either after a single cube is built or after a row or whatever you want. If you don't put this in here, you can just build the entire world by zipping through all of the loops in one go, but you won't see it being built. And the other problem is if you set this world size way too high, then you will crash Unity. And if you can see it being built step by step and you've got this I enumerator that is yielding and actually having a pause in its function, then you can quit your world if it's getting way too big when you're trying to run it in the editor. So I will warn you now, we're starting at 2 and you might want to ramp this up to 200 straight away. Do not do it, as you're about to see. It's really not a good idea. Okay, so inside our build world method here, you can see the 3 for loops that we've already investigated. So I've got the Z on the outer, I've got the Y, and then I've got the X on the inside. And what these are doing is looping through all the different coordinate values in your 3D world between 0 and world size in each dimension. Now each time X comes around, it's going to build a new vector, which will be the position of the particular cube it's about to make. So we're just putting it at X, Y, Z. The reason we can get away with putting a single cube at X, Y, Z each time and not have them overlap is that each cube, each default Unity cube, is 1 in size. So we're working with whole numbers and we're working with cube sizes that are exactly 1. It makes the math in this world so much easier to work like that. So the cube is instantiated from a block and it's set to the position that we've calculated up here and at a 0 rotation, because the rotation in this case doesn't really matter. Next, I'm also giving the cube that's being created a name based on its X, Y, and Z value so that you can see where it is. And I guess you can see it in the transform as well, but it also helps to identify and find it later on. Now, after the X, I've got the yield. If you want to yield after each single cube, you would move this yield up into here, inside the X loop. The issue I had there is it was just way too slow. So this will build sort of one row at a time and then keep yielding for you so you can see that going on. Now, just down below that, which is doing all of the work for us, I've got a start function, which will start the coroutine for build world. And there's nothing inside of the update. All right, so let's save that and switch back into Unity. Now what you want to do, if you select the world object in the hierarchy, is that it needs to have a block. And the block is our prefabbed cube. So in the hierarchy, right click and create a 3D object cube. There it is. Now it will automatically be 1 by 1 by 1 in size, which is exactly what we want. With that cube, drag and drop it into the project, and that will create a prefab out of it. In the hierarchy, let's just remove it. We don't need it anymore. And select the world again, and you want to drag and drop the cube prefab onto the exposed block variable there. And now this cube will be used to build our world. So let's press play and have a look what happens. Okay, so that happened quite fast there because there's only a world which is 2 by 2 by 2. And if you go to the scene view, you'll be able to select each individual cube. So you can see that cube there, if I move it out, is at 0 in the X, 1 in the Y, and 0 in the Z. So the names have been added here. You'll see something called a fake cam target. That's being used by the script that we added to our camera so we could move it around in the game view. So you'll find if you're in game view, you can use the Alt key to orbit and the Q to move around. So it's very handy for seeing what we're building. And for each project we create from now on, you should just bring that in anyway until we start creating first-person controllers and those sorts of things. All right, so that's your cube. Now, if we just stop running this and go back to world, and let's put in 5 in this case for the world size and press play, you get a much bigger cube made of many little cubes. So it's now 5 by 5 by 5. And now let's go back to our world and ramp it up to, let's say, 30 cubes and press play. Now this is where that yield comes in handy because it allows us to still have control over our game environment without freezing the whole thing while it's trying to finish building all of those cubes. And you can see it being constructed row by row by row in this case. Now imagine you want to build a world the size of Minecraft. This is going to be quite a slow process, isn't it? And the idea of building a world like Minecraft just from cubes sounds like a good idea because cubes are just so convenient. But when it comes to rendering it out, it's a really bad idea. So the more cubes you get, the more lag that you will get in the environment. And as I've said previously, there aren't any cubes in Minecraft, which is the genius of it. So we're going to now investigate what's going on with all of these cubes and have a look at how adding more and more cubes on affect the performance of your game. So let's stop playing. Go back and change your world size to 2 so that we're only working with 2 by 2 by 2 lots of cubes in the world. Then we'll press play again. And this time in the game window, we're going to open up the stats area. So there's a little button at the top called stats. And if you open that up, you can see some of the performance factors of the game you're running now. Of particular interest to us in developing this voxel world is to look at the frames per second and the number of batches. Frames per second is how many updates to the screen you're getting per second. Now, if this falls down below 20, you'll start to get jitteriness and lagging in your game world. So the human eye is capable of detecting smooth movement in anything above 15 frames per second, and regular film is shot at 24 frames per second, which makes it really quite smooth. In fast action things like games, you need much higher frames per second to fit in all of the action and to create smooth movement. So I'm currently running at 80 frames per second, which is really good on my machine. Yours might show a different value here. And considering we've only got 8 cubes sitting in the environment, you wouldn't think this is going to drop very low for that. Now, the batches tells you how many things need to be processed before you get an image on the screen. And this is running everything through the CPU and the GPU. So Unity here is putting everything that needs to be drawn onto screen, which is your geometry and any shaders, materials, textures, that sort of thing, lighting as well. It's batching them together into 7 batches, and therefore it's looping through 7 times, and then bam, you get an image on the screen. Then it'll do another 7 processes and you'll get another image on the screen. And it's telling us that it's also saved 28 batches or 28 lots of things by putting them into these 7 batches. Contained in those 7 batches are 400 triangles, which make up all of these cubes, and 800 vertices. And we will look at the geometry of cubes in a little while. But for now, of course, the more cubes you've got, the more triangles and vertices that you're going to have. So this is at 800 frames per second, 7 batches for a world that is 2 by 2 by 2. Now, what I'd like you to do as a little bit of an experiment for yourself is to run this with a world size of 2 and write down the frames per second, and then stop running, and let's change it to 4 and press play. And then once it's finished drawing, write down again the frames per second and keep incrementing and doubling this. So then go to 8 and run it and write down the corresponding frames per second. And what we're going to do is to graph them. So here's my graph of frames per second versus the world size. And you can see that it went along okay, holding at about 80 frames per second until it got to a world that was around 12 by 12 by 12. From there, performance dropped dramatically, and around 32 by 32 by 32 in world size, I was getting 3 frames per second. Now currently, every cube that we are generating is sharing the same material. So Unity is doing its best to batch up our geometry, and anything that has the same material on it can be batched together. But when materials are different, it can't batch them, and the performance goes down even more. So let's have a look at that. Go into your world script. Let's open that up. And in here, each time we instantiate a new cube, we're going to just add in this line. What this will do is grab hold of the current material that's on the cube and set it to a new material. And in this case, we're just making it a standard shader, but it will still be a different shader on every single cube that's generated. So now save that and go back into Unity and run the experiment again by changing the world size. What you can see from my own experiment is that the cubes with their own individual materials, shown in red here, the performance drops off much more dramatically than it did before when they all used the same material. But we still get a rapid decline in the performance. What this tells us is when we go about our business of creating a very blocky world, we need to take into consideration the number of materials and the number of meshes that are in it. And therefore, right from the outset, we need to go back and consider these things by completely reinventing the cube.